बिस्मिल्लाहिर्रहमानिर्रहीम। हम एक बहुत इंपॉर्टेंट टॉपिक पे जो बहुत ही निगलेक्टेड है इस वक्त, लोड फ्लो एनालिसिस। और ये लोड फ्लो एनालिसिस में बड़ी इसलिए इम्पोर्टेंस है कि हम जितने कंसल्टेंट हैं, मैं पहले अपना थोड़ा सा इंट्रोडक्शन करा दूं कि आई बिलोंग टू यूनाइटेड लिंक सर्विसेज। दिस इज़ अ कंसल्टिंग फर्म doing some sort of design works, electrical audit, energy audit, safety audit, etc. The lot of works we are doing, even the arc flash analysis. लोड फ्लो एनालिसिस एक लिहाज से इसलिए इम्पोर्टेंट है कि ये जब आप डिज़ाइन बना लेते हैं तो वो इम्प्लीमेंट नहीं होता वहाँ पे, तो उसकी जो है ना लोड फ्लो का एनालिसिस करना बड़ा ज़रूरी है, ताकि इसका जो है ना क्या कहते हैं, ये इसका एनालिसिस आप कर सकें कि जो है ना ये आपके पास ये जो है ना कि लोड की जब ये इम्प्लीमेंट होगा, एग्जीक्यूट होगा, तो इसकी क्या कंडीशंस आएंगी। तो यूनाइटेड नेशन सर्विसेज इसमें काफ़ी वेबिनार कर रही है। हर महीने हम दो दो वेबिनार कर रहे हैं। और लोड फ्लो एनालिसिस में हम एक्चुअली ई टैप का भी इस्तेमाल करेंगे। पहले मैं इंट्रोडक्शन दे दूं। और आजकल इसकी इंपॉर्टेंस इसलिए भी बढ़ गई है कि जितनी नेट मीटरिंग और आपकी जो है ना क्या कहते हैं सिंक्रोनाइजेशन वगैरह के हवाले से ये यूटिलिटी कंपनियां या जिससे आप एफिलेट हो रहे हैं, लोड फ्लो एनालिसिस मांगता है। तो इसमें मैकेनिकल भी कैलकुलेशन का हम कुछ आइडिया देंगे, लेकिन अगर आपके पास कोई जो है ना क्या कहते हैं ई टैप वगैरह या कोई सॉफ्टवेयर है तो वो उसमें बहुत आसान है। इम्पोर्टेंस बहुत है कि मतलब अगर आप भी किसी को आउटसोर्स करते हैं डिज़ाइन के लिए भी किसी कंसल्टेंट को, तो उसको बोले कि इस डिज़ाइन का लोड फ्लो भी दे, तो एक्चुअली उसकी और उसकी टाइम मॉडलिंग भी हो सकती है कि किस टाइम पे क्या ये किस तरह एग्जीक्यूट होगा, इसके पैरामीटर्स क्या होंगे। तो वो सारे पैरामीटर्स मेरे साथ मेरे कोलीग्स हैं सैफुल्लाह बलोच साहब, वो भी इसमें प्रेजेंटेशन ई टैप वगैरह की देंगे आपके साथ। वो इसके साथ एक प्रेजेंटेशन देंगे आपके साथ, कोशिश करेंगे कि आपको एक्सप्लेन करें। एक छोटी सी इस शॉर्ट टाइम में शायद पूरा ना भी हो सके, लेकिन जितना हो सकेगा हम इंशाल्लाह पूरी कोशिश करेंगे कि आपके साथ कंट्रीब्यूट कर सकें। और इसमें कोई कमेंट्स हो तो आप हमें दें ताकि हम इसको और इम्प्रूव कर सकें। पहले तो इसकी टर्मिनोलॉजी बिल्कुल समझ लें। और ये हमने लिया है IEEE का स्टैंडर्ड। मुझे तो ये बहुत है, आईसी में भी है, IEEE में भी है, और आपको VDA में भी मिल जाएगा, आपको कैनेडियन हर में कोड में कुछ ये IEEE का एक स्टैंडर्ड है 3002.2 और 2018 का। इसके मुताबिक हमने ये प्रेजेंटेशन बनाई है और आपके सामने इसकी प्रैक्टिकल इम्प्लीकेशन की बात करते हैं आपके साथ यहाँ पे। और इसका है रिकमेंडेड प्रैक्टिसेस फॉर कंडक्टिंग लोड फ्लो स्टडीज, एनालिसिस ऑफ इंडस्ट्रियल एंड कमर्शियल पावर सिस्टम। और ये एनालिसिस इसलिए ज़रूरी है कि आप पेपर पे सारा डिज़ाइन कर लेते हैं, लेकिन उसकी जो प्रैक्टिकल इम्प्लीमेंटेशन में जो प्रॉब्लम्स आएंगे वो इसको फोरसी नहीं कर सकते, क्योंकि अभी प्लांट लगा ही नहीं है, अभी आपने उसको एग्जीक्यूट करना है। तो इस एग्जीक्यूशन में जो प्रॉब्लम्स आएंगे वो ये सारा पिन पॉइंट कर देगा आपके साथ सामने, आपके सामने सब काफ़ी चीज़ें क्लियर हो जाएंगी। और अगर मैं इंट्रोडक्शन इसका मैं थोड़ा सा दूंगा, उसके बाद सैफुल्लाह बलोच साहब इसको टेक्निकल डिटेल्स में ज़्यादा हो जाएंगे। लोड फ्लो इज आल्सो रिफर टू एज अ पावर फ्लो। These terms may be interchangeably used in this standard. This is the name given to a network solution that predicts steady state currents, voltage, and real and reactive power flows through every branch and bus in the system. Load flow studies simulate operating conditions that cannot practically be experienced on the actual system. यही चीज़ मैंने आपसे बात की भी है कि अभी प्रोजेक्ट लगा ही नहीं है तो ये सारी डाटा हमें मिल नहीं सकता, ये सिमुलेट कर सकता है। Because the system has not yet been built, because of the practical constraints of time, or because it would be unwise to expose the actual physical system to conditions that are potentially damaging. The end objective of the load flow study is not always to arrive at hard numerical performance parameter. Often the objective is to gain insight into how the system performs over a range of operating conditions. इसीलिए इसकी टाइम मॉडलिंग के भी सॉफ्टवेयर बनाने पड़ते हैं और इसकी इंपॉर्टेंस बहुत ज़्यादा है। मतलब ये कि मैं आपको बताऊँ, टू वेरीफाई द ऑपरेशन ऑफ ए नेटवर्क अंडर वेरियस लोड एंड जनरेशन कंडीशन, टू प्लान द फ्यूचर ग्रोथ ऑफ बोथ लोड्स एंड जनरेशन, to determine the best economical operation for existing system, to establish initial condition for stability study. सिस्टम की स्टेबिलिटी के लिए बहुत ही ज़रूरी है यहाँ पे। और इसमें अगर सॉफ्टवेयर करें तो बहुत आसान हो जाएगा, जो अभी आपको पता चल जाएगा। टू हेल्प आइडेंटिफाई द नीड फॉर एडिशनल कैपेसिटिव और इंडक्टिव वीआर, अगर आपका रिएक्टर्स अगर आपकी कम बन रही है तो केवीए रिएक्टिव कैसे ऐड किया जाए। टू मेंटेन सिस्टम वोल्टेज विद इन एक्सेप्टेबल लिमिट, वोल्टेज ड्रॉप अपनी लिमिट से ज़्यादा ना हो, इसलिए वीआर की सपोर्ट भी देते हैं ट्रांसमिशन लाइंस वगैरह पे. Load flow results are very valuable for setting the proper protective devices to avoid noise and stripping and improve system stability. One of the most common computational procedures used in power system is the load flow calculation. The planning, design, and operation of power system requires such calculation to analyze the steady state performance of the power system under various operating conditions and to study the effects of changes in equipment configuration. Typical results from steady-state load flow include power flow in each branch circuit, source loading, voltage magnitude, phase angle, etc. ये सारे पैरामीटर्स हैं जो आपको सारी चीज़ें चाहे मैनुअल कैलकुलेशन कर लें चाहे सॉफ्टवेयर से कर लें, सारे पैरामीटर्स आपको पता चल जाएंगे. For some types of equipment, photovoltaic solar arrays or wind farms, a time-varying simulation such as a time-domain load flow may be required in order to fully understand the behavior of the electrical system over a period. These time-varying load flow solutions are performed using computer programs designed specifically for this purpose. Analyzing the solution of this problem for numerous conditions helps ensure that power system is designed to satisfy its performance criteria while incurring the most favorable investment and operation cost. Some examples: component of circuit loading, steady state bus voltage, real and reactive power flows, transformer tap settings and load top changer action, system real and reactive power losses and voltage drops, performance under maximum, normal, minimum and startup loading condition, performance under various operating conditions such as cogen, on or off type breaker, close, etc., performance under emergency condition, requirement of either fixed or variable power factor improvement equipment, real and reactive power demands and voltage drop at utility source connection, generator exciter, regulator voltage set point, under voltage and over voltage condition for buses as well as equipment terminals. अब ये रिक्वायर्ड इनपुट डाटा के हवाले से जो इसकी अब टेक्निकल है थोड़ा सा ज़्यादा, जो मैनुअल कैलकुलेशन प्लस सॉफ्टवेयर जो हमने ई टैप से इस्तेमाल किया है, ये सैफुल्लाह बुलंद साहब आपके सामने आ रहे हैं.
Assalamualaikum everyone. So from now onwards I will continue regarding this load flow analysis. So the very basic thing which we need in designing such a system which can calculate the load flow of any lumped network, any distribution network or any commercial power system. So for that we need some data, and that is called required input data. So first of all, I would like to tell you something about the basic and general system data which we need to put in the design, need to put in that software or any either. If you are using any manual method, then you also need such data, na? So for most load flow programs perform their calculation using per unit representation of the system rather than working with the actual volt, ampere and ohms. As you all know, being an electrical engineer, that a per unit system is very important and very produce and very easiness in calculating different electrical parameters, because in per unit system, if any changes occur in the actual parameters of the system, you don't need to change the whole calculation. You either need to change a single data or just 2 or 3 steps, because per unit system generalizes the data and it converts the actual data with the base values, and then it will gives you any per unit system. The input data to the program can either be in per unit system, percentage, or in actual unit, depending on the design of the program or any desired you can say calculation method which you are using. You can insert your data in that form. Now you need to convert your system into per unit units of calculation by using the base values, and in base values we need base MVA, which is the power, and base voltage, that is base kV. When if you have a system having thousands of volt like in commercial or in industrial power systems, there is a MVA and kVA ratings for these parameters. Now for that base MVA, base voltage, base kV, you need base impedance as well as base current of the system. For these computer based programs, softwares, they automatically calculate your base values, or either if you are inserting yourself such base value, they will select them by their own desired or predefined parameters, that which value they have to select. Like in manual calculation, we used to select the highest value. So that same procedure that computer also obeys, that it connects, it uses that highest value as a base value for the system calculation. Like if there are 100 MVA, 10 MVA, 20 MVA, these are the different power ratings given on the different parts of the system or components of the system. It will select automatically 100 MVA as the base MVA. Okay, now the base kVA is chosen for each voltage level. Oh, this is same in the manual in calculation. As you know, that base kVA, you have to be sure that you need to select kVA base kV for each component as per the point of you can say point of inspection. It depends upon that thing. Now let me tell you something about a very basic thing which is not very important, because in software calculation, this data is automatically generated by the computer. That is the bus data. Now bus ID, name or number, if you want to manually insert that, you can also do that thing. But as the computer is so much smart, it can already it already helps you, it already generates that data. It refers it it put in itself a bus name for each bus you are selecting or inserting. Bus classification, now this is an option which you want to select: swing bus, voltage control bus, or load bus. Now in the next slides we are going to explain these types, but for this instance you need to just understand that this selection of buses, types of buses, you can also do it manually on that computer based system. Now bus service, if you want to keep that bus in service or out of service, that status you have to select, or either you have to leave or totally depend on the computer based programs. Bus nominal voltage, now this voltage data is automatically generated, automatically you can say is dedicated to that bus by the computer, because whenever you connect any source to that common bus or any sub branch, that bus takes that voltage as its own common voltage. Like if you are connecting the secondary of a transformer to a bus, and if the secondary is rated with 415 volt, then that bus will automatically gives you the data that my common voltage or bus common voltage is 415 volt. So this is automatically generated data. Now bus rating and continuous amp, this depends upon the material which you are using on the as a manufactured, that bus is manufactured like for on the copper, aluminum, or any other material which your computer based program is giving you that option. In many different programs we have different materials. In ETAP we have two types of material, that is copper or aluminum. On that basis, on that material specification, it will allow you to select the ampere rating or continuous ampere rating. Initial voltage and angle, that we are going to be discussing in the next slides, inshallah. Now load types and data, that what kind of load and what data regarding that load you need to insert. There are different kinds of loads, like inductive, reactive, capacitive, inductive, capacitive, and voltage controlled, like these things. In load flow simulation, the voltage magnitudes and phase angle of the in phase angle of load terminals are calculated. They change according to overall loading and network condition. So these are the changes which actually simulates the real time scenarios, that whenever the loading on the system is increased, or the load or the system get overloaded, then there may be different changes occur, like in voltage magnitude, phase angle. So this will allow you to have a real time you can say face of that system, that how the system will perform and react on these loadings and different change of parameters. The load characteristics will also change according to the terminal voltage and phase angle changes. Now the load which is entertained by the source, if you are keeping that load constant, and if you are changing the terminal voltage and the angle, that loading may be changed, that load characteristic may also change. because in real time in our typical systems this scenario occurs, and this reaction of the system can also be experienced in such softwares. A load bus need not have load. It may simply be an interconnection point for two or more lines. Now, if you are saying that this dedicated, or this, for example, A or B bus is a load bus, it does not mean that it contains itself a load. Maybe it is a connection point between two buses, and it is behaving as a common point for two different lines, and they are having load. So there can be indirect or direct loads on that load bus. In this case, Kirchhoff's law requires the sum of the real and reactive power flows in the bus equals the sum of the flows of the out of the bus. So this is a basic requirement for the verification of electrical data, that whatever parameters like in voltage, like in power, that whatever is the, like if we are saying in the power flow, that whatever amount of power is flowing in that bus, it must go out of that bus. And this gives you a verification of the Kirchhoff's law, and it gives you that your calculation is correct. Because if there may be a difference between input or output data, there may be something which is getting lost or going any stray, you can say, parameter. So you need to have to be careful. But in computer based programs you don't need to worry about such thing, because they have a more smart methods of calculation, so they can easily simulate such data. Okay, for simulation purpose, loads are often defined as the following types. Now, I'm just going to give you a short review of these kinds of load. That constant kVA load, that power of that system, power of that load is predefined, that this amount of power will flow. So this is a constant kVA load. It will not affect the changes in kVA, and it will not affect the system, whatever system parameters, voltage or phase angle changes, but this constant kVA load will be remain same. Constant impedance load, now these are typically used for a motor which is starting, or for many static non-motor loads, like such appliances which have which are called static loads. In simulation, I have also these kind of loads connected to that system which I'm going to simulate in front of you guys. There will be a static load which having a constant impedance load, so that the parameters like voltage or any other electrical parameter which we are inserting, that will not affect the impedance of the load. The impedance will remain same. If it is 12 ohms, it will remain 12 ohms. Whatever the phase angle, whatever the voltage, whatever the current it may flow, it does not changes the impedance of the system. Constant power and constant current loads. So this is actually some other kind of you can say a kind of load which make it assure that current in that load remains the same, and the power must be you can say the power consumption of that load will remain same. For example, if any load is running on, like a fan or a energy saver, and for example voltage drops, so now what happens, that the system will increase its currents, the system will start to consume more current, so that power of the system, power consumption will remain constant, and as well as current of the system must remain constant. So this you can say this most of the time this kind of loads give you a constant power instead of constant current actually. So this is actually you can say a kind of load which you have experienced in most of the time, like for example some kinds of static power conversion equipment, and these kind of loads are constant power and constant current loads. Generic load, sorry, for the constant power and constant current load, I would like to add some point. There is some misunderstanding in my explanation, I think, which I have just delivered to you. Sorry for that. I would like to correct myself. constant power and constant current load means if voltage, if you can say current is decreased, of if the current supply is decreasing to the load, and if the load needs the constant power, so it will actually lowers the voltage and the current will remain constant and power consumption of that load will remain constant. So this is actually the basic definition. You need to make it correct if you are noting it down. Generic load used as general complex load, where the real and reactive power are complex function of the terminal voltage. So these loads that varies the power flow. Na? So this actually depending upon the terminal voltage and frequency. That is totally depending upon these two electrical parameters. If the voltage and frequency of the system and or to the supply changes, then it will automatically affect the flow of real and reactive power. Okay, so the most common scenario is for loads to be megawatt, and MVAR reactive at nominal voltage. This load is treated as constant MVA load that is independent of the voltage. In some cases, a constant current or constant impedance component of load could be entered, so the load is a function of voltage. The load data are used to represent the load as various location depending on the design of the software. Load type or data include some of all the followings. Now these things you have to put in that software, or if you are doing a manual calculation, the load identification, what kind of load you are using, load is in service or out of service, the operating condition. You have to be careful that either it is a continuous one, intermittent, or spare. Real reactive power reactive, because whenever you are purchasing something from the market, you can see a nameplate having such data. Rated power factor and efficiency, what is the rated one? There is a difference between the rated one and the actual power factor. That actually depends upon the scenario, that actually depends upon the current circumstances of the load, or the supply, that what the supply is behaving, or what the you can say input that supply is giving to the load, that changes the power factor. And there is a rated power factor on which the manufacturer gives you the full efficiency, that if in on such and such efficiency you such as a power factor, you will get this amount of efficiency. Okay, loading in percent of rated power for different operating conditions. So this thing you will find in the computer based programs, where you are being asked that how much percentage of loading you want to put on that system. For example, if your load is 20 megawatt, then it will ask you either you want to put 80% of the load, 90%, or the 70% of the load. So this will also conclude the efficiency, that if you are having low power factor or load factor, it will automatically decline your efficiency. Now load demand factor, static loads, electronic load, lumped load. Now this static loads are constant impedance load. These are simple, very basic loads. Electronic loads are constant current loads. As you used to find in your surroundings, there are hundreds of electronics. These are called electronic loads. And lumped loads are actually, you can say, lumped load is itself a network of different connected loads. Okay, so lump, if anyone say you a lumped load, it means lumped means different networks are being interconnected to form a complete power system. That is a lumped load, and that power system can be of 1 kilowatt to 1 megawatt or thousands of megawatt. So that is that terminology lumped. You have to keep in mind that meaning, the what it actually refers. Most of the time people get confused with the static load nomination, you can say the sign which we are using for lumped load and static load, na? So you need to just understand the difference between these two. Okay, so now for the motor loads, these are constant kVA loads. You have to also be careful that how much efficiency you are demanding. Either it is 100%, 75%, or 50%, and as well as loading. Then how much loading you are putting on that motor. And this load flow data for motors may also apply to other studies. So this data is also applicable for short circuit and motor acceleration calculation, especially in ETAP. Okay, because of this, most software allows the input of motor load entered as a mechanical load curves. So most of the time, if you are using any software having such load flow calculation for the motors especially, then it may ask you the motor mechanical input and output power. So this thing, if you are having such software, you need to have such data referring with the needs of that software. Motor loading can be derived by using these load curves as well. Generator data, so generator data is also defined on that nameplate, or any, if you are assuming any data, then you need to have voltage, that current, that rated power on these things actually depend upon uh, generator identification, generator nameplate ratings, generator operating mode. Okay, swing, voltage control, MVR control, motor power factor control. So these are the different operating modes. Like in the next slide, next two or three slides, we are going to explain such types of the load. And this will also refer to the generator operating mode. Scheduled voltage magnitude, that is voltage control, scheduled real power output in megawatt. So these are the different data which you need to put in the software. Okay, now swing bus. Just uh, giving you an short overview. Swing bus is that kind of bus which is called as voltage and phase angle bus. Simply, or either you can also say it swing bus or select bus. Okay, it will give you the data that swing bus has it already every time, that is voltage and the phase angle of that voltage, or you can say also the voltage magnitude as well as the voltage phase shift, that how much angle that voltage have, many times you see on that in academic people must have been experience of these things, that whenever we call any bus as a swing bus, it must have a data of voltage and the phase angle. Now it it is responsible for the balanced power flow in that system. Whatever the voltage is, whatever the power demanded by the load, it this bus is responsible for supplying that amount of power, the desired need of this load. If the load is rated at 1 megawatt, and after some time in future it grows up and it demands you 2 megawatt, then this bus is responsible to increase that power generation and gives the supply and balance the supply and demand of this system. Most of the time the generator which are connected in the commercial or industrial power system, they are they are operated in a swing mode, that if the load is increasing, the generator start to increase at rpm or any electrical parameter which is according to the setting of that generator, according to the parameter of the generator, it will start to supply that power. Okay, so in the absence of the if there are many generators connected with each other, then the largest generator is selected as a swing source. And in the absence of the generator, the grid is referred as a swing bus, because as we know, the WAPDA or any utility company, that is infinite power supplier, infinite power utility. So it is referred as a infinite bus. So in the absence of generator, the grid is actually referred as a swing bus, and it is responsible to the power flow. And swing bus, as I already told you, it is an infinite source. uh, if we call it in a real time parameters, it is not actually infinite, it is finite, but it is larger to with as comparison with the other kind of sources. Now this uh, voltage controlled bus actually uh, is a bus in which voltage magnitude is already defined to the source, that this must be constant whatever the power is flowing. If the power is increased, and if this power increase changes the voltage, the source must keep the priority for the voltage controlled, because voltage must not change. uh, it is sometimes installed with such loads where the voltage constant ness is very important, that voltage must not be changed. If the voltage is changed or it is lowered or declined, the load may be get affected by such voltage decline. And if the power demand is increased, then it must shut down before the voltage is get down or get lowers. Okay, for this reason, the generator is also defined as a PV source where the quantities theta and Q vary according to the power demand. Generator bus actually gives you two main datas, that is power and voltage. And in this voltage control bus, which are called generator bus, this voltage control bus has another name that is called generator bus. In academia we find two names: generator voltage control bus and generator bus. Okay, so in this predefined data you will get voltage and the power of that particular bus. And in this supply, in such kind of supply, you will find that the reactive power and the phase angle changes according to the network demand. Now branch data, branches can be of parallel or series. It depends upon the system needs. Or there can be transmission line, cables, series reactor, series capacitor and transformers. Okay, so for the branch data you need to insert physical length, resistance is ohm, resistance. You can also have per unit parameters for this reactance, line continuous amperage rating. So these are the data you need to put. Okay, transformer data are like transformer having a different data you need to, which you are required to insert, like transformer cooling class, transformer altitude, transformer ambient temperature, transformer rated primary and secondary voltage, transformer x by r ratio, transformer impedance, transformer positive sequence and zero sequence. And these different status, that either transformer is in service or out of service, transformer identification, the insulation class, if you and the types of transformer, three winding or two winding or one winding, or this thing, tape setting, phase shift in degrees. If you are having this kind of transformer, like if you are having a star delta parallel connection, these things you have to already specify and that input data. Okay, so methodology and standards. Now, there are different kinds of methods: manual and as well as digital computer based you can say methods, which are conducted on the loads flow simulation softwares. In earlier era, in early era, we don't have such improved or developed technology for using this for calculating load flow. So at that time we were using the two different methods that both were manual and that were developed by the different engineers. Okay, so before going on these methods, I would like to give you some tips on the problem formulation, that how you will actually set the data whenever you are getting any manual problem. Na? So for that, we have voltage and phase angle at the swing bus. This is the input data which you will get already from the the problem. Voltage magnitude and active power for the PV bus, that is voltage control bus or generator bus, that both are same. Active power and reactive power for PQ bus, that is the load bus. Okay, so we here, as I've already explained to you before, that there are three buses: swing bus, voltage control bus and load bus. Now, these things you will find that variable given that are knowns and which include real power and voltage magnitude for the generator from the load select bus. Now select bus, you don't need to confuse, that is the swing bus, that is voltage angle and voltage magnitude that will be given. So these are the known and unknowns. Okay, so variable found unknowns, that is the voltage angle, reactive power you have to find, voltage angle, voltage magnitude for the load bus or generator bus. Okay, for the real power and reactive power. So these are the buses. Okay, which in which you have to find these unknowns. So this is the problem simulation. Now, for this these are the three matrices you are find matrices you will find here. This is a simple linear equation which is given as a Ohm's law. I is equal to YV. This Y is actually the impedance and it is in matrix. So that is called impedance matrix. And it is also called nodal admittance matrix because these admittances are pointed at the nodes of the electrical system. Now, these are the calculation. As we know that I is actually the power flow plus divided by the voltage. So this is simply a power formula. S is equal to IV, and by some rearrangement uh, we have got this I value here, that is I is equal to P plus JQ1 upon V. Now this I value we are going to put in equation number 3, which will give you the equation number 4. This equation. Now there are two techniques: Gauss-Seidel iterative technique and Newton-Raphson iterative technique. Now if you'll just Google this term, iterative technique, iterative method, iterative process. This iterative actually refers to a kind of process in which you are not getting the answer in a one step, but you start to have this method 2, 3, 4 times, or in such number of times in which you are getting to that desired accuracy of that answer. As we know, in some engineering real-time complex problems, we are not getting the answers directly according to that our need. So for getting that answer, we have just a target, and the target is accuracy. So after putting that values again and again, after getting a single value from one time step, you have to put that answer again in that technique. You will get another answer, that another answer you have to put third time. So this will improve your answer, and it will give you a target accuracy. Then if you reach at that desired accuracy, you will find that answer to be correct. Okay, so this is called iterative technique. So Gauss-Seidel iterative technique, these are the you can say mathematical calculation. Here bus 1 is a here is an example of a 3 bus DC system. Bus 1 is a reference bus because reference bus is always chosen as a select bus or swing bus or voltage control sorry, a constant voltage bus. You can see here the voltage is defined here, so we will call this bus as a voltage bus. Now this is a generator bus and this is a load bus. Okay, in this on the bus 3 we are having the three different loads are connected and no power insertion from this bus, so we will call as a load bus. Now this is a matrices which you will find here because there are 3 buses, so you will get a matrix of 3 by 3 for the nodal admittance matrix, and there are 3 currents, 3 voltages for each of that. Now these are the rules. I'm not going into depth calculation because this is a pure mathematics and this is not so tough, because if you start to do that one, this is just putting of values and that equations and getting your answers, putting of the data. So I'm not going to in that depth one for these calculation, because it will get the system topic will get bored, and already already it is in very you can say very technical topic. So I would rather go for these manual calculation. I would like to choose the software based. So just giving an overview, Gauss-Seidel method is kind of insufficient method because it contains a lots of steps, and the convergence sometimes, for example, if you are getting accuracy of 10% after every step, and at some moment, like if you have reached to 70% accuracy and you want 90% accuracy, then after the 70%, if you go with the again that step, again the next step, you will find the accuracy going down. So sometimes Gauss-Seidel technique is failed. So for that, the Newton-Raphson iterative method is used, and for this Newton-Raphson method, there is one advantage and one favor which we are getting, that this convergence of answer is minimized, and the number of steps in Newton-Raphson methods is decreased, and for different complex kind of problem, the Newton-Raphson method is applicable. So again, I'm just giving an image. In this method, the Jacobian matrix is very important in the place of that because it contains partial derivative of different what is it. So here we have different examples, the practical example which we have just put in this presentation. If anyone wants, they can email us and we will be sending you this. Okay, so you can read it by yourself. This is not so difficult. This is just a medical calculation. If someone is having you can say bachelor's, or if he or she is in their second or third year, or even final if they are in final year, so it will be easy for them. So before not wasting much time, we are going to have a software application for this load flow analysis. Let me just close this presentation or minimize it. Okay, so now we are having this. Okay, so now, ladies and gentlemen, we are having a power system having a utility. Yeah, ET. So utility, let me just, so now I'm going to revise all that thing which I have already told you in the presentation. Just not that so long, which I have that time I have consumed in the presentation, but giving a short overview and that data, especially that data which I have asked, told you that I will be putting that, or we need to put if you want a load flow calculation or load flow analysis for any desired system. So for the power grid, we are having a ID. Okay, so ID, it says that it is a utility supply. Okay, so this is a bus 4, and connection is 3 phase. This is a 3 phase bus, and the service is in, and state is new, future, moved, modified, or whatever. And we are in very typical calculation, we just put this as built. Okay, configuration is configuration is normal. For the operation mode, we have a swing bus, voltage control, MVR control, power factor control. So as I've already told you that in the absence of large generators, we are using the grid as a swing mode, swing operation mode. So I have just here clicked on the swing mode. Now, if you want to put a tag or name or description of that, you can also put right over here. Rating. Okay, rating. For the rating, we have a rated kV for that one, and it is a balanced one. Okay, balanced one means it has no unsymmetrical parameters in that bus. Operating condition, the voltage is 100%. I will not allow any kind of decline in the voltage in that bus, in that utility. What is the voltage angle? That is the operating voltage angle, which gives you an origin. So I am starting from the origin. Now what is the MVA and megawatt rating? That uh, power grid operating real time. So you can change it by yourself, but for the this small or commercial, small industrial power system, we have 250 megawatt is enough for that. MVA. No, 250 megawatt. This you can also select the MVA rating for that, but I'm giving it a okay. Now short circuit rating, that is MVA short circuit. That for the 3 phase I have selected 250, and if you are having the you can say 500 kilowatt or any big utility company, you can also select 500 make you can say
500
MVA.
is the max.
500 is the
250
maximum.
is the minimum.
Yeah, 500 is the maximum rating which you will find on that for any utility
Of the
company.
utilities
Yeah,
and
yeah, for the utility. Okay. So this time domain, this is not very important because we are having a general power load flow. So we are not going to use this time domain. Harmonics. Okay. For harmonics, you can also select different data from this one, that what kind of harmonics you want to experience in these you can say power in this power system. But for the general calculation we are not having we are not using this power harmonics. Reliability. So these are the data which you will find if you want to experience a real-time simulation, then you can get from the utility company that what is the reliability. Like here it is mentioned that 0.643 failure per year. So this is a constant term which you will get from your utility company. But
not valid for Pakistani
yeah, not valid for Pakistani company nowadays because they will not share this data with you. Okay, because this is most of the time it get confidential. So just for the manual for the general calculation, the software will automatically gives you a general data for that. Energy price. So we are not here for the economic view. So we are ignoring that. Remarks and comments. What do you like to put in this? Okay,
performance parameters
performance parameter. Okay,
under different load conditions.
yeah. So this is the transformer. Now this is very interesting one here because many of you people may come from the came from the engineering you can say background. So here you will find the different input data which you have already learned in your academia or any company which you are now working. So this is the ID T1. If I put here transformer 1 or transformer 1 this alphabetically here. Okay, so this is also connected with the 11 kV. Here it's showing it is connected with the primary is connected with the bus 4, that is 11 kV, because here you can see in the system that this is connected with the utility supply. Okay, now which standard you are following? That is ANSI, that is American National Standards of Unit. Okay, and another one is IEC, International Electrotechnical Council. So in Pakistan and generally in European countries, we are following IEC. Now this is an in-service state which already defined in the grid. Okay, so this is a shell type core 3 lamp. The lamp is, for example, if you have saw, if you have just may have, many of may have seen the transformer completely open. So there are different types like shell type, or there are core type having 3 lumps for each phase, 4 lumps, 5 lumps, or one single phase. So this is the type of construction which we are using in the transformer. Okay, so here we are selecting the shell type. Okay, now rating. The primary is rated over here. The full load amperage, it will calculate itself. Like for example, if I'm putting 12 kV, it will change the full load ampere. And if I'm having 11 kV, it will give you 78.78 full load ampere. This FLA actually refers to full load amperage. Now secondary, I have rated it 0.415 kilovolt. So that is automatically 415 volt, and the full load amperage is 2087. Now here we have a kVA for this transformer. Like if you want to change it, you can also change it here. Power rating, if you want to put in MVA, kVA, or if you want to change the rating, like for example 1500 kVA, you can change it. You can also put,
Stay with 1500 kV or
yeah,
whatever.
15 or 2000 kVA. So here you can see the data is changed. The data, the full load amperage is automatically changed. Just after, if I change the power rating, it will automatically change the primary rated current and the secondary rated current. Now here we are selecting the 1500 kVA. Okay, derated. Now this is the derated. Now derating factor is actually depending upon the condition given. Okay, user defined. Now if this is the alert maximum derated kVA, for example, if I'm putting is 1200, okay, let me just change it. Derated it after some, you can say, malfunction, it may have a change in the rating of the transformer. Sorry, let me just change it out. Okay, so this is the liquid type of that, liquid fill or dry transformer. Many of the typical industrial power system or commercial power system, we are using the liquid filled, that is the oil filled transformer. What is the subtype? That is the mineral oil, synthetic liquid with having different rating, non-flammable synthetic liquid. So these are the liquid types which you are using in. Okay, class. Here we have different class of cooling, that is actually referring to the cooling class. ON, AN, oil natural, air natural, uh, oil natural, wind natural, oil natural, wind natural, oil natural, air natural, oil natural, air natural, oil natural, air forced. Now oil is naturally, you can say, flowing in the transformer, and air force means the fans are inserted or installed near the transformer for the huge amount of wind to put. Yeah, forced draft fans are used for the cooling system. Okay, so here we are having a basic one, that is all natural, air natural, like the distribution transformer. Okay, temperature rise, we are selecting the 65. For the ambient temperature, the environment which you are using, like in Karachi, we are having 45 degrees. Okay, so depending on this ambient temperature, it is having a D rating itself. For example, like in 30-degree, it was giving complete 1500 kVA, and when I selected 45 degrees Celsius, it has given you a D rating of 14%, and it changes the transformer rating from 1500 kVA to 1290. That is the 1300. So this 1200 kVA is affected because of this temperature rise. Okay, now impedance. For the positive sequence, generally when you are having a 15 kVA, for the by the IEEE standard 242, that is same in the IEC standard, we have to select the positive sequence impedance, that is 5.72, and X by R ratio, it is also defined by the IEEE 242, and same in the IEC, that is 6.5 percentage, this reactance percentage, resistance, this we have just inserted the data. Okay, now no load test data, here we don't need to put, because we have no such calculation, because for used for the unbalanced load power flow only. Okay, now tape setting, what kind of percent tape, like in distribution transformer or power transformers, we have different tape settings. Okay, so you can also change this tape setting from here. What grounding you are using, that is prime, if you are using a primary as a star, we have to select the grounding, either is a open or is a solid. But for the like distribution transformer, we are having a delta as a primary, and for the secondary we are having a star connection. Okay, so for the grounding, solid, and we are having, as you can see, different earthing: open, solid, resistor, reactor, solid earthing. Yeah, but in these systems we are using a solid earthing. And if you want to find the resistance, that is neutral grounding, reactor resistance, we have also had a webinar just few months ago, I think 1 or 2 months ago, that you can also go and see there, that what kind of parameters you need for such, and what is the benefits and disadvantages of these kind of groundings. Okay, now sizing. Okay, transformer loading, you can also select from here. Protection, which you would like to put over here. I'm not going in depth, because I don't want to give you a complete detailed one of now. It will be, inshallah, we are going to have a training for the ETAP So in that one, we are going to give you a completely detailed step-by-step calculation and parameter insertion for these different components. But for here, you just need to go, in a general specific way, and then you can explore it by yourself. Now, for same as like grid in data. हाँ हाँ that इनको मैं बता दूँ वो लास्ट में जब होगा harmonics. So for the harmonics we are having a different data which we can also insert, but for this general perspective we don't want to go for this step. Okay, so this is an high voltage circuit breaker. This is the rating which you need to select. Either you want to use both, you can use American standard or IEC standard, or for the rated kVA, for the rated amperage you can also change here. Making capacity, breaking capacity. So I'm not going to define these two, these two or other terminologies which are very basic. If you are an electrical engineer, you must know about this making peak capacity or breaking capacity. That what are these things, no? Reliability, interlocking. If you want to put like for example two circuit breakers together, and if you want to have a interlocking between two things, you can also have this. Okay, now for the bus setting, these are the different settings which you want to put, which you have to put. Here you can select the material of conductor type, aluminum or copper. As I've already told you that there are two types which you will find in the E-tab. What is the height of, width of that shock protection, that is according to NFPA 70E. Okay, so this is the simple as circuit breaker. This is the another bus, because between circuit breaker and motor or any load you have to connect a bus. Okay, you have to give a common bus for this breaker to work. If you just disconnect this bus, this motor will, or this any load will not connect directly to the circuit breaker. So this is a predefined setting in the ecodial, sorry, ETAP. Now for the motor, you have you can say these different ratings, nameplate. You can select in horsepower. You can have a full load amperage, efficiency, power factor. Like for example, if I change this horsepower to 10, it will allow me to select the different kind of motors. Like for any, according to NEC, according to okay, is this existing one, and next one, this is the MFR. Okay, so this is the user manufactured data. Okay, so it will, whenever you just change the power rating of that motor, it will give you the different ratings of amperage, power factor, efficiency, kilowatt ampere. This it will, and from the library you can also select the different types. Okay, here you have also different options. So this all is okay. Inertia, load of the motor, model of the motor, cable
Inertia of the secondary device.
yeah, for the secondary device, starting drive. If you want to add any starting like stator resistor or any controlling device,
Star delta, delta.
yeah, star delta, whatever you want to put. Okay, so these are the user friendliness of ETAP. These are the static loads. These are just simple loads which are having a constant power and sorry, constant kVA load. Here we have, I have selected only the kilowatt load. I have not inserted any reactive load over here, and we are having a star grounded load. Okay, this is a star grounded load. Now just giving an overview, and in the inshallah in the next webinar, or in next time we are going to arrange an ETAP training. So I'm going to give you a depth, you can say, explanation for these different interfaces. Now for being now, I'm just going to tell you that how you will select a power flow. So here you have your different options, like this is a load flow, but this is a for balanced one. This is the short circuit, arc flash, motor acceleration. This is harmonics, transient stability, and here you will find the unbalanced load flow. So I have switched from the, like, for this is an editing mode. Here you will construct the single line diagram, and now I'm going to change the presentation view to the unbalanced load flow. So I have now different options here. Now I'm going to generate an unbalanced load flow. Okay, so now you can see you have got this parameters over here, that this is the power flow, 899.9 kilowatt plus 339.8 kVAR reactive. So this is the power flow of this utility company to the transformer. Now this is what the actually 5.37 kilowatt, that is the power which is consumed over here. Okay, these are the losses. Let me just clear. Acha, okay. Now, for the easiness, it has an also option of display options. That what kind of thing you want to, want to check. Like for example, if I want to have a kVA rating, if I want to have a power flow in like kVA, I need to just choose it over here. Okay, for the ampere, I can also have this option, that if I want to know the ampere flow only, so I can select the ampere. But here, if we are choosing a kVA, and this is the bus magnitude, bus angle, load terminal voltages. And if you want to know the load line voltage or phase voltage, you can also select it from this. L and N means phase voltage, and for L and N, that is the line to line voltage. Now what results you want to know? Branch, source, load, composite motor or composite network. For example, if I am selecting the branch, source and load, so it will only show you these data. So here you have different options. And voltage drop, if you want to know the voltage of cable, load, you can also select. For example, if I am selecting the line voltage drop, so you can also say, okay, now what kind of values? All phases, all sequence, or average value? Let me just put over here that this is an average value or all phases, but for the easiness we are selecting the all phases value. Okay, now branch losses, if you want to know the losses of complete the reactive losses and the real power losses, then you can select this one, kilowatt plus j kVAR. Okay, if you want to know the S, that is the apparent power losses, the total losses, you can select over here. Okay, now for the meters you can also select the M meter over here. And for the AC, you can also check out here the different fuse rating, meter rating, relay. You can also select that if you want to know the ID rating, kilovolt, or if you want to know about the phases, you can also select it. So these are the, okay, so this is the power flow, okay, in each phase over here from this utility company to the transformer. And this is the loss, 35.3 kVA is the loss at the transformer secondary, and this is the power flowing from each in each phase from this transformer secondary to the bus. This is the power consumed by the motor, and these are the voltage, these are the power flow, 1.86. Let me just check it. Okay, let me just change it. I think I have just, okay, this is a component network. No, this is the phases. Okay, okay, this is the voltages of each phase between AB, BC, CA. So this is the you can say voltages which at the terminal of the motor. This is the power flow, same. These are the angles. These are also the angles. So this is the data which you are getting, and this is the bus voltages here, and the bus, you can say bus sequences, bus angles. Okay. So as you can see, this power flow in this load is here 32, and the motor is 63.7 kV. So these are the parameters which you will get in the load flow. And in the display option, you can also have, you can say, you can change the unit if you want to want the unit to be shown over here, and you can also produce generate a report for that. And if you want to just change the unit, like here, you can see kVA. Okay, this is ampere. Okay, this is the kilowatt plus kVAR loading. And if you want to change the voltage angle, voltage percentage, like for if you want the voltage in percentage, you will see here 98.25 the voltage. Okay, so these are the options. Yeah, within limit. Now this is the you can say the phases. Either you want to give the all phases ratings here. Okay, if you want to know the average rating, you can also select from here. So this is the terminal, show the voltage terminal. Okay, so these are the terminal voltage. This is the line or voltage drops. Okay, so this is the show line or cable voltage drop. So you can also select get from this data. So I think that is enough for today. If you would like to, yeah, if you like to have any question, you can also ask. Okay, so yeah, why you have select unbalanced load flow? That is because in this system we have no balanced loads. Okay.
Generally, utility system are unbalanced.
Yeah, utility, because we are having different loads having different characters, so there can be unbalanced, you can say, character of the system. So for
in
that,
industrial plant, you can take the balanced load, but in the commercial distribution,
yeah,
it will be unbalanced.
yeah, for the unbalanced. Okay. Yeah, so for this purpose I have selected the unbalanced load flow. Can you share the recording of the session? Please email us or just write down your email in the chat box. We will be emailing you for the
YouTube also.
Yeah, you can also, yeah, in couple of days you will also get on YouTube channel. Okay, that is our YouTube channel. Let me just put the link over here. So this is the link you will find in 1 or 2 days. Okay, please share PPT. Sayyid Danial Ali. Okay, Danial Ali Sahab, inshallah we will be sending you via email. Any other question you would like to ask?
Just mail us.
Okay, you can also mail us, and with that,
Thank you.
Okay, thank you very much for your time, for joining us. For any query, you can also mail us, and inshallah, we will be having a hands-on training for this ETAP. If you guys would like to join us, you can also just keep updated with our YouTube channel, and as well as your email. We will be emailing you regarding the training. Inshallah, we will meet soon. Thank you very much. Allah Hafiz.